This is a recording of Chapter 12, Mineral and Rock Resources, which are non-renewable. So we start with earth materials, and that includes minerals. A mineral is an element, for example, copper or aluminum, or inorganic compound, for example, salt or quartz, that occurs naturally in the Earth's crust as a solid with a regular internal crystalline structure. A few minerals consist of a single element, such as gold, silver, and diamond. Diamond is made of carbon. Most minerals are compounds of more than one element, for example, quartz and feldspar. We use a variety of non-renewable mineral resources. A mineral resource is a concentration of a material from the Earth's crust that can be extracted and processed into raw materials and useful products. Mineral resources are generally considered to be non-renewable. So some examples of mineral resources that we use are metallic ones, which are aluminum, gold, and copper, or non-metallic like sand and limestone. So here we have examples: sand, which is mostly composed of silicon dioxide, which is the same thing as quartz. And sand is used in the production of glass, bricks, and concrete. And then limestone is another example, and that's made of calcium carbonate, or calcite is the same thing. And limestone is crushed and used in making concrete and cement, and also in the production of lime products, such as calcium oxide or calcium hydroxide, which are used in different industries. So what is a rock? A rock is a solid material made of minerals, volcanic glass, or aggregates of plant remains, which would be coal, for example, or animal remains, such as rocks composed of seashell fragments. Monomineralic rocks are made of only one mineral, like limestone and quartzite. Most rocks consist of more than one mineral, however, and that would be like granite or basalt. What is an ore? An ore is a rock that contains a large enough concentration of a particular mineral, for example, a metal, to make it profitable for mining and for processing. So for example, you have the ore called bauxite, which is shown in this photo. Bauxite is where aluminum is mainly derived from. So the rock is called bauxite, and it has enough aluminum in it to make it profitable to mine and process the bauxite to extract the aluminum. And by the way, when they show a photo of this and they show a penny, the penny is just for scale. Sometimes when you have pictures of rocks, you'll see little objects to show the scale of the photo. So all metal resources that we use have a life cycle. Each step in the life cycle uses large amounts of water and energy and produces waste and pollution. So we see the life cycle down here at the bottom of the slide. First, we start out with mining, where you extract the ores, for example, the bauxite, and then you separate the rocky material from the metal. You separate the materials from the ore, and then you go into the smelting process. You melt the metal and then convert it to whatever type of product you want to. And then in this case, when you discard the product, you could recycle it, smelt it, and melt it back down into a liquid metal, and then reuse it in a different way. Some environmental impacts of mineral use. The mining, processing, and using of a metal takes enormous amounts of energy and water, and it can disturb the land, especially when you're in the mining process. You are basically ripping apart the land. It causes a soil erosion, produces lots of solid waste. It could also lead to air pollution, water pollution, and soil pollution. So recycling is really important because if we recycle metals such as aluminum, then there would be less need for mining and processing the ore, and less need for mining, and then you would have less of an impact on the environment. So then we're going to get into different types of mining. So mining, you have shallow mineral deposits that are removed. That is surface mining. And that's going to include removing vegetation first from the land. So you might cut down parts of a forest so that you can get to the mineral deposits. Removing the overburden, which is any soil and rocks that are overlying whatever mineral deposit you want access to. And then you're going to set aside that waste material, the soil and rock material. You're going to set that aside in piles called spoils. Subsurface mining removes minerals from underground through tunnels and shafts. So that's going to be for deeper mineral deposits, whereas surface mining is for shallow deposits. Subsurface is for deeper deposits. So this is showing you on the left a diagram of coal mining, and it could go pretty deep. Okay, you also have very deep mines when you have gold mining. Okay, some of these mines can go very, very deep. And then here on the right is a photo of someone down underground in a coal mine. So there are 4 different types of surface mining, and it depends on the resource being sought and the nature of the land overlying the resource. So on the left, this is a picture of strip mining for coal in Wyoming. So these are the 4 types of surface mining: open pit mining, strip mining, contour strip mining, and mountaintop removal. So open pit mining is when machines dig large holes in the ground and remove rock from the open pit. And the rock that's removed can be metal ores, sand, gravel, limestone, marble, different things like that. Open pit mining is only feasible in areas where rocks and sediment deposits that lie above the ores, which is called the overburden, are able to be removed easily, or if the materials that you're looking for to mine are already close to or at the surface. Strip mining and contour strip mining is the next one. Strip mining is when you extract mineral deposits that lie in large horizontal beds close to the Earth's surface. So this is a picture from Bear Valley Strip Mine in Pennsylvania. And you see rocks here that are bare, and they used to have layers of coal, and the layers of coal have been removed. So you had this whole section that was filled in with coal, and it was removed as a strip of coal. So that's a strip mine. And when the coal is gone, it's abandoned. It's generally just an abandoned mine then. Mountaintop removal uses explosives, large shovels, large power shovels, and huge machines called drag lines to remove the top of a mountain and expose seams of coal, which are then extracted. This is a common process to remove coal in the Appalachian region of the US. So this photo here is mountaintop removal in West Virginia. And there were harmful effects of mountaintop removal mining because you're destroying large vasts of forests, and the overburden that is removed when you remove parts of the mountain rock that can bury mountain streams and increase flood hazards. Another harmful effect of mining in general is that wastewater and toxic sludge is produced when coal is processed, which can release toxic substances into the environment, including arsenic and mercury. So subsurface mining disturbs less land than surface mining, and it usually produces less waste material. But when you mine underground, it could create hazards like cave-ins, explosions, and fires. Miners could also get diseases called black lung disease, which is caused by prolonged inhalation of coal dust in these underground mines. Also, you can have subsidence where the land above the mine collapses. So separating the metals from the waste material in the ores produces waste piles called tailings. And then particles of toxic metals in the tailings can be blown in the wind or leached by rainfall and can end up contaminating surface and groundwater. So the actual removal of the metals from the ores has harmful environmental effects, as well as the mining for the ores, which also has harmful environmental effects. And this is a photo of bauxite tailings. Chemicals may also be used to remove metals from their ores, and that could also cause harmful environmental effects. For example, solutions of cyanide salts can be used to extract gold from its ore. So heating ores to release the metals from them is called smelting. Without effective pollution control equipment, smelters emit enormous amounts of air pollution, including sulfur dioxide and suspended particles, which then would lead to soot being in the air, and it could lead to acid rain. The sulfur dioxide specifically would lead to acid rain. This is just a photo of an aluminum smelter. So mineral resources are distributed unevenly around the world. The Earth's crust contains fairly abundant deposits of iron and aluminum, but then other elements like manganese, chromium, cobalt, and platinum are relatively scarce. So there are 5 nations that supply most of the non-renewable mineral resources that are used by modern societies. Those 5 nations include the US, Canada, Russia, South Africa, and Australia. Experts are concerned about 4 strategic metal resources: manganese, cobalt, chromium, and platinum, which are essential for the US economy and military, but the US has little or no reserves of these metals. So we rely on other countries to get these 4 metals that are really important for us. The future supply of non-renewable minerals depends on 2 factors: the actual supply of the mineral on Earth and the rate at which we use it. So minerals may become economically depleted when it costs more than it is worth to find, extract, transport, and process the remaining deposits of the mineral or the ores. But we do have some options when this does occur. We can recycle and reuse existing supplies. We can waste less and use less, or find a substitute, or just do without. So we can find substitutes for some scarce mineral resources. And that is a materials revolution that we're seeing. And that is where we're using a lot of silicon and other new materials, particularly ceramics and plastics. And they're being used as replacements for metals. For example, something like a fiber optic glass cable can replace copper and aluminum wire in telephone cables. A more sustainable way to use non-renewable mineral resources is to recycle or reuse them. And this is especially important for valuable or scarce metals such as gold, copper, and aluminum. We could clean up and reuse items instead of melting and reprocessing, which is recycling. And that has an even lower environmental impact. So reusing has a lower environmental impact than recycling. Then we have something called rare earth metals. These are 17 elements that are designated as rare earth metals. And you could see this list here, okay? And they are on this chart here, the periodic table of elements. So rare earth metals are used in computer memory, DVDs, rechargeable batteries, cell phones, catalytic converters, magnets, fluorescent lighting, etc. And you have this pie chart here that shows uses of rare earth elements. And we need these rare earth metals, and the US military also uses these in night vision goggles, precision guided weapons, communications equipment, GPS equipment, batteries, other defense electronics. Okay, so all of these aforementioned materials and equipment all require rare earth metals. So China dominates the rare earth metal trade. And on the next slide, I have a link to a video on concerns over the trade wars and possible effects on our access to necessary resources. And you could see here, this shows you rare earth element production, and it shows you different countries. So you have China is in red, and that's the most metric tons out of all the other countries on this chart. Hold on. Okay, so here is a list of videos that you could watch about rare earth metals. Okay, and the video that I was referring to on the previous slide is this one. The one that says Reuters. Also, I have a podcast posted on Blackboard about rare earth metals. It's from a recent 60 Minutes episode. So now we could move on to chapter 13.